Okay, today we're going to be learning about trig identities. These are some identities that you need to memorize. You should already know that tangent is sine over cosine and that cotangent is cosine over sine. You also already know these reciprocal identities, that cosine is the reciprocal of secant, secant is the reciprocal of cosine, sine is the reciprocal of cosecant, and cosecant is the reciprocal of sine. These three Pythagorean identities are really all you would need to memorize, since these are the new ones. Sine squared plus cosine squared of theta is equal to 1. 1 plus tangent squared of theta equals secant squared of theta. And 1 plus cotangent squared of theta is equal to cosecant squared of theta. So that's just something that you guys will need to memorize. We're going to start by verifying identities. So we're claiming that sine of theta times secant of theta times cotangent of theta is equal to 1. So really we're going to just try to write everything in terms of sine, cosine, and tangent. We're only changing one side. We're going to change the more complicated side. So we're going to change the left side here. We're going to leave sine as sine. Secant of theta we can rewrite as 1 over cosine. And cotangent of theta we can write as cosine over sine. And once we do this, our claim is that this is equal to 1. So we can see that the cosines would cancel and the sines would cancel, leaving us with just 1 is equal to 1, and that's how we have verified that identity. Number 2, we're going to leave this as sine of theta, so we can rewrite this as sine of theta. Stays sine of theta, but we can rewrite cosecant of theta as 1 over sine of theta. So that's sine of theta divided by 1 over sine of theta. We're claiming that's equal to sine squared of theta. So we can rewrite this when we divide by fraction. It's the same as multiplying by the reciprocal. So that's sine of theta times the reciprocal of 1 over sine of theta, which is sine of theta over 1. And again, we're claiming that's equal to sine squared of theta. And sine times sine of theta is sine squared of theta. So then we have sine squared of theta is equal to sine squared of theta. Okay, number 3 is pretty much the same. We can look at number 4. Now number 4, this says 1 minus sine squared of theta. So what we're going to have to do is we're going to have to look at one of these Pythagorean identities. Okay? We can rewrite sine squared plus cosine squared of theta equals 1 by, if we subtracted sine squared of theta from both sides, then that would give us cosine squared of theta equals 1 minus sine squared of theta. So we can rewrite 1 minus sine squared of theta with what it's equal to, which is cosine squared of theta. So that's cosine squared of theta over cosine squared of theta equals 1, and anything divided by itself is 1, so 1 is equal to 1. So we have just verified that identity. So let's look at number 8. On number 8, we can rewrite this as, we can break this up into sine of theta over sine of theta plus cosine of theta over sine of theta. And we want that to be equal to 1 plus the cotangent of theta. Anything divided by itself is 1. And we can see that cosine over sine is equal to cotangent. So that's 1 plus cotangent theta equals 1 plus cotangent of theta. So we have verified that. What we can do on number 9 is we can multiply these out using the distributive property. 1, 2, and then we distribute 3, 4. So 1 times 1 is 1. 1 times sine of theta is sine of theta. Negative sine of theta times 1 is negative sine of theta. And negative sine of theta times sine of theta is negative sine squared of theta. The sines of theta cancel out, and that leaves us with 1 minus sine squared of theta. And we want that to be equal to cosine squared of theta. Well, if you look up here, remember that cosine squared of theta is equal to 1 minus sine squared of theta. So I can replace 1 minus sine squared of theta with cosine squared of theta. We get cosine squared of theta is equal to cosine squared of theta. So we have just verified that identity. Okay, let's look here. Can you see those top problems? See them there. Let me take this down. Okay, let's look at which one? Ooh. Let's look at number 10. Okay, on number 10, remember we can only change one side, and on number 10, the left side is what maybe looks more complicated, so I'm going to change that side. We can rewrite tan of theta as sine of theta over cosine of theta. And we can rewrite cotangent of theta as cosine of theta over sine of theta. Okay? And again, we want this equal to secant of theta, cosecant of theta. So what we can do next is we can't add these right now because in order for us to add fractions, we need a common denominator. So for us to get a common denominator, we would have to multiply top and bottom here by sine of theta, and the top and bottom here by cosine of theta. That gives us sine squared of theta over sine of theta, cosine of theta, plus cosine squared of theta over sine of theta, cosine of theta, is equal to secant of theta times the cosecant of theta. Now that we have a common denominator, we can write these two over the same denominator. So that's sine squared of theta plus cosine squared of theta all over sine of theta, cosine of theta. We want that to be equal to secant of theta, cosecant of theta. One of our Pythagorean identities is that the sine squared of theta plus the cosine squared of theta is equal to 1. So really we have 1 over the sine of theta, cosine of theta. But you know sine of theta, cosine of theta, we could write that as 1 over sine of theta times 1 over cosine of theta. And remember that 1 over sine of theta is just cosecant of theta, and 1 over cosine of theta is just secant of theta, which is what we wanted it to be equal to. So we have now verified that identity. We could do one more. Let's look at number 17. Okay, so number 17. Secant squared of theta minus tangent squared of theta equals 1. Remember, one of our Pythagorean identities is 1 plus, I don't know if y'all can see it right there, 1 plus tangent squared of theta equals secant squared of theta. So what we want to do is we want to get we want to get 1 by itself. So to get it by itself, we'd have to subtract both sides by tangent squared of theta, which would leave us with 1 is equal to secant squared of theta minus tangent squared of theta. So just by that identity, we can verify that 1 is equal to 1. I'll do one more with you guys. We can look at number 12. So number 12, we can edit this left side. And we know that this is secant squared of theta. We could leave that as secant squared of theta. And then remember that secant is 1 over cosine squared of theta, right? So that's secant squared of theta minus 1 over cosine squared of theta times cosine squared of theta. And these two would cancel out, leaving us with secant squared of theta minus 1 is equal to tangent squared of theta. Now to verify this identity, we're going to have to go back to this Pythagorean identity, which is 1 plus tangent squared of theta equals secant squared of theta. We want to get the tangent squared by itself, so we'd subtract 1 from both sides. So remember that the regular identity is 1 plus tangent squared of theta equals secant squared of theta. But we want to get tangent by itself. So if we subtract 1, then we can see that tangent squared of theta is equal to secant squared of theta minus 1. So that means that secant squared of theta minus 1 is tangent squared of theta. So tangent squared of theta equals tangent squared of theta. Okay, so what I would like for you guys to do for homework is I would like for you guys to do number 16. I would like for you to do number 11. I would like for you to do number 20. And I would like for you to do number 3, 5, and 6, okay? 3, 5, and 6. So homework is number 3, 5, 6, 11, 16, and 20. Okay? Let me know if you guys have any questions.